The fold_r function is probably the most complicated, but also the most powerful of the higher order functions. It is also known as reduce or accumulate, but its name comes from the idea of folding values into a single value. If we look at the signature, we see that the fold_r function consumes a function, an initial y value, and a list of x in order to produce a final y value. The function that it consumes an x and a y, specifically the current y, and produces the next y value. So the idea is it's iteratively building up new y values based on the initial, modified using each element of the list and the current function. And it finally produces some special final y. Let's look at an example, specifically summing a list. So fold_r with the plus function on 0, and we pass it in a list of numbers like 3, 5, 2. If we call this, it will sum up the list of numbers. The first argument of fold_r must be a function that consumes two things, a current element of x and the current folded so far value of y. It will produce the next version of folded so far, which will be a y but a different y. For summing, we use the addition function. The next argument is a starting point of the folded value. If we had passed in an empty list, this is a value that would be returned. So if we had passed in empty instead of the list 352, it would return 0. If you're summing an empty list, blah, 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 you pass in an actual list of values for the third parameter. Mechanically, the plus function will be called in each element of the list one at a time. Let's break this down step by step. So we start off with 0, and then we add the first element, which is 3, producing the new value 3. So our x was 3, and our y current is initially 0, down here, and that produces the new value y next. We'll use the arrow over. And let's actually make these match up. 3 plus 0 leads to 3. Then we'll do the next element mixed with the current value, so we carry the 3 forward down here, and we take the next value of the list, the 5, and that produces 8. Then we take the next value of the list, which is 2, carry forward the value from the previous iteration, 8, and produce 10. And that's our final y value. Notice how the original list is the first column here, 3, 5, 2. The result of each computation gets carried forward into the next iteration. It makes it pretty hard to reason about fold_r, but it also makes it very powerful. Let's try another example. This time we'll join some strings. So we'll fold_r using the string append function. The initial string is an empty string, and then we'll say, what a doggo. All joined together becomes what a doggo. We can even do this with actually a list of images. So let's require in toHTTP/image. Then we can define shapes as being a list of, say, a circle, a solid green circle, and we dropped a parentheses here, calling a function. Then we'll also make a triangle of size 18, make it solid red, and finally a nice rectangle of size 20 by 10, and it will be a solid blue. Alright, so we'll run this, and that'll define a new shapes list. If we call shapes, it produces a list of 3 shapes. If we want to turn this into a single image, fold_r, we can use the beside function, passing an empty image as the default case, the base case, and that puts them into 1. So you notice that when we call shapes, we don't have an image. But if we call the result of fold_r, we do have an image. In this case, we combine all of them into a single image as opposed to a list of images, two separate ideas.